We'll see two questions are very important, that is you can think real analysis question or anything, but giving with modern algebra only, because they are asking also including modern algebra. So see how to find. Complex roots of unity and all I gave, no? That is in group theory itself I finished. So you see just one 5-degree polynomial given have and asking exactly real roots and all. How to find solution? I will give here two methods. First method, whatever I will give, that is called a discard roots of signs. Okay. By that also maximum sometime we can find solution. We can cancel option and we can find solution. But here exactly roots and all telling. So for exactly another method have to apply. So both I will learn you. Both you can apply. First, this is a 5-degree polynomial, odd degree polynomial. So must at least root must be real. So here first option we can cancel, f has no real root. This is wrong statement. Here we can write degree of fx is odd. So fx has at least one real root. Must one real root have. After the exactly one real root, exactly 3 real root, all roots are real asking. Okay. Here after discard rule of sign we will go. By sign we can find. Whatever fx given have, how many changes of sign have? Plus 2 minus 1 minus 2 plus 1 2. So f of x has 2 changes of sign. This is the method. How many changes of sign have to see. So we can write f of x has at most 2 positive real root. At most this is no root. At most means either 2 positive real root or 1 positive real root, otherwise no positive real root. This is the meaning. Again x place we will replace f of minus x. Then what will happen? X power 5 have, so minus plus 5x plus 2. So how many changes of sign have here? Only one. One changes of sign. This meaning f of x has only one, sorry, only not, at most one negative real root. Means either one negative real root, otherwise no real root. This meaning here confirmation came, f of x has at most 3 real root. At most 3 real means out of 5 roots, at most 3 real root will happen. At most means no real root also possible, but degree odd have, so no real root we can't tell. Means we here we can write finally f of x has at least 1 real root and at most 3 real root. So this is confirmation, have remaining 2 roots, confirm complex, at least 2 roots, 5-degree polynomial. Out of 5-degree polynomial, 3 roots, suppose that real coming. So 2 roots will be complex. But here at most 3 real root have, means real root will decrease also possibility. Means minimum 1 or maximum 3. That is the meaning. So if real root will decrease, then complex how many will come? At least 2 complex roots in conjugate pair. This is real coefficients polynomial. So complex whenever will increase, conjugate pair will increase. So at least 2 complex roots or 4 complex roots possibility have. This meaning either 1 real root will happen or 4 complex roots. Or if real roots not decreasing, then 3 real roots will happen and 2 complex roots will happen. If real roots decreasing, then two real roots not possible. If two real root means three complex root not possible. So either one real root or three real root or two complex root. Okay. So finally here we can write, and then f of x has at least two complex in conjugate pair. So here confirmation came that all roots are not real, that is confirmed, and yeah, first option wrong and D option wrong, all roots are not real. So hereafter exactly one real root will happen or exactly three real. Here this exactly word they gave. So hereafter by this method we can't cancel. Sometime this and all they won't give cancel, one option will be correct. So here confirmation came finally either one real root or three real root and at least two complex root. So finally f of x has either one real root or two real root not possible or three real root, and at least here at least use two complex root in conjugate pair, because if real will decrease means this will go direct 4, so at least 2. So anyhow complex they are not asking about real root. So hereafter for exact concept we will go sign scheme method, sign scheme or by numerical analysis concept, bisection method also telling, go no problem, bisection method we will use. Okay, so what is bisection? No anything, just a real line only. You can use before also. This is my target is I am learning method. Sometime you use direct this method, direct solution will come, but you use discard rule of sign, no, that will help more. In this our target have how many positive negative, because between one positive between one negative one roots will exist. Okay, so that concept here have to apply, discard rule of sign, bisection method. So here confirmation have that in positive side at most two positive real root and negative side at least one, at most one negative real root. So we will see here positive side plus minus minimum two pair will come, and here only one pair will come. Okay, so what is f of 0? X power polynomial is what I have here written have. So f of 0 will be 2, so positive. We'll try negative side before, because this side any one minus will get means one root confirm. F of minus 1 what will happen? Minus 1 means minus plus 5 plus 2 positive. This is positive. F of minus 2, yeah, minus 2 power 5 plus 10 plus 2 negative will come, because this is minus 32 plus 12 negative will come. Finish. So one positive one negative we got it in negative side. So one root must existing between this alpha. This here after confirmation this is. Before at most we are telling no, one plus minus got, one root must will exist between them, and here after don't verify. Here after this is continuously negative will come, because already we verified negative side at most one negative real root. So leave it. Here after positive side go. Positive side if we are getting at least one real root, no, then confirm three real root, because two real root not possible, either one or three. So no need to verify. So f of 0 is positive already have, f of 1. Anyhow f of 1 is negative. F of 1 is negative. So finish. Here one real root will come, beta, then three real root. Exam hall don't check here after. Direct three, exactly three real root. Okay, but we can verify. F of 2 what will happen? F of 2 35 positive will come, 10 plus 2 positive. So confirm three real root, f of 2 will be positive. So one root between minus 2 to minus 1, one root between 0 to 1, one root between 1 to 2. Okay, so three exactly real root. Finish. This is our solution. Okay, this concept is like this only. Theorem we can write means Another one question we'll see. Today you stay her home. Otherwise, come my home, stay with Kinsu till 1 o'clock play. Till Kinsu have no in my home. You play till 1 o'clock. Every day I am playing. Today you come my home. I will give food to you as a guest. See this question. In this question, no, we can't apply discard rule of sign, because discard rule of sign only we can apply in polynomial form. But here direct